just fix it later. Okay. Okay, here we go. If you have a highlighter, good as well. So in permutations, when we're talking permutations, what we've been doing so far, sometimes we use the counting principle, sometimes we use permutation. It's basically the same thing. In permutations, the order of the elements matters, right? Picking the first number and the second number, like if you make a password, let's just do a 2-digit password, let's say. You typing in 1 2 or 2 1 makes a big difference, right? The system is not going to let you in if you get these wrong. So the order does matter. This is a completely different password than this. Okay? They're different. Okay? However, so A, B, and BA are considered two possible outcomes. When dealing with combinations, the order does not matter. Okay? A, B, and BA are considered the same outcome in this case. So that's particularly the case when you're making groups, when you're making teams, correct? Does it matter if you're in the same, when you're in the same team with a person, with another individual? Order doesn't matter as long as you're in the same team, right? So picking 6 numbers on a lottery ticket, it doesn't matter which number you pick first. You have your 6 numbers, and that is a combination. Choosing or selecting members for a committee or a team. Downloading apps on your iPhone, on your phone. Oops, I said iPhone. Sorry, just phone. We're not all iPhone lovers, right? Even though iPhones are the best, in my opinion. But that's just my humble opinion. So there's you have the apps on your phone. It doesn't matter what order they're in. You have that theme, right? Hand of cards, right? If you get dealt a card like a hand, does it matter which order you arrange them in when you're playing the game? No, you have that hand, right? That's your hand. So the formula for combination is very similar. What's different about combination versus permutation? Is it on here? No, permutation is the other booklet, but this is the only difference here. Permutation just looks like that. Combination has that R, the number of elements, factorial to it. Okay, let's put a little note here. If you ever see n C0, from n number of elements we choose 0, that's automatically 1. Okay, it's going to help you out big time. We'll write this down. NCN, if these two numbers are the same, basically, then it's also just 1. If you have NC1, your answer will be N. And if you have NC, N minus 1, your answer is N as well. And you're like, scratch, scratch. What are you talking about, Mr. Dirksen? Typing in combinations is just as painful as typing in permutations. So if you know some right off the bat like this, it's going to save you a lot of time. Watch. I'm going to give you examples here. If you have 5, choose 0. From a team of from 5 available candidates, you choose 0. That is just 1. For various reasons, it turns out to be 1. If you use this formula, you would get 1. If it's 5, choose 5, let's say, right? These numbers are exactly the same. It's also just 1. If it's 5, choose 1, 5, choose 1, then the answer is just whatever this is. It's 5 in this case. If it's 5, choose 1 less than this that you start, whatever it is. If it's 5, choose 4, it's just 5. Okay. If it's 99, choose 98, the answer is 99. Okay. So this is just a little note here. It's going to help you out for what we're about to do. So let's consider the following case here. Consider Anna, Bernadette, and Clara. Anna, Bernadette, Clara. If you were asked to arrange them to take pictures, right? That would be considered a permutation. So you would have, let's write this down, A, B, C. A, let's flip C and B, right? A, C, B. Then let's start with Bernadette, Anna, and Clara. Bernadette, Clara, and Anna. And then let's have Clara in the front. Clara, Anna, Bernadette, Clara, Bernadette, Anna, right? You have 6 different outcomes, 6 different permutations slash or arrangements. Okay, that's that. And you can confirm this using either the counting principle, right? We would go, right, if you're arranging them, it's 3 times 2 times 1, which is 6, right? Or you could use permutation notation where out of 3, you're going to pick 3 to arrange. So no repetition, of course. That is still 6. So that all jives, right? Now let's do combinations. I'm going to split this here. I'm going to copy what I just did here. So please do that as well. It's going to help you out, trust me. Let's do the same thing, BCA, CAB, and CBA. Probably faster than me at doing this. With combination, order does not matter. Okay, combination, when you're doing combination, all of this is just considered one group. Okay, so it doesn't matter which order you're in, all of these arrangements will be considered just one group when you're talking combination. Okay, so let's put that into place. So if it's 3, choose 3. If you realize it's a combination question, out of 3, you have to choose 3. Let's use our formula up here from up here. It's 3 factorial, right? N factorial over R factorial. And underneath you have N minus R factorial. And this is 3 factorial over 3 factorial. What's 3 minus 3? 0 factorial. We all know that that is 1, right? So when you cancel everything out, this is just 1. This 3 factorial divided by 3 factorial is? It's not 0. Nice try. It's 1. Okay. So basically, when you're dealing with combination, it gets rid of that 3 factorial, that gets rid of the what under permutation we consider unique. Under combination, that is not, it doesn't matter which order you're in. All of these would be considered just one permutation or one group. Okay, so if you're still scratching your head, just follow me, just come along for the ride. I'll show you more examples. Okay, so let's go to page 46. There are 12 hockey players. Go Jets go, right? Hopefully today. 12 hockey players. How many ways can a coach pick a right wing, left wing, center, right defender, left defender for her starting lineup? I want to make a note here. Write this down. You notice specific positions, right? Specific positions are mentioned. Does order matter? I will say yes, right? If you pick John to be the right wing or John to be the left wing, it's a different lineup, right? So specific position is telling you that order matters. So another scenario would be, hey, president, vice president, secretary, treasurer, those are specific positions. So that's going to be definitely order matters. So here we go. This is going to be, you have 12 for the right wing, 11 left for left wing, center, right defender, left defender. And so that's how you would fill those positions, right? Or you would simply say 12, pick 5, right? Regardless of how you do it, you get 95,040 lineups. right? Right? If Shifley is defender, right? If Shifley, the Winnipeg Jets player, is a defender or center, it makes a different team, right? It's a different team. So it does matter. What if the question said, right, can pick 5 players for a starting lineup, no positions, just make a team of 5 players. Okay, just make a team of 5. So let's put this in a different context. Just pick 5 random books. Hey, how many 5 books can you pick from 12 possible authors, right? Doesn't matter the order that you do them in. So order does not matter here. So I want you to see it side by side. Let me just zoom out a little bit because you can't see that exclamation. Order does not matter here. Therefore, combination question. Right? Combination question. Can I just go up here? Order matters. Therefore, permutation. Sorry about that. Okay, this was a permutation question. This is a combination question. It all has to do with does the order matter? And specific positions is like a guaranteed slam dunk permutation question. Guaranteed. If it's just making a team, oh, combinations. Okay, so we have 12 players. We're going to choose 5. It actually often is choosing. You're choosing things, right, to make a team. I will use the formula 12 factorial over r factorial, and then it's 12 minus 5 factorial. Let's simplify that. You must know how to simplify. Soon I'm going to ask you to simplify completely by hand. Sometimes I don't even care what the final answer is. So 12 factorial, I'm going to break that down. Watch. Because this is 7 factorial here, so I'm going to go 7 factorial, stop there. I'm left with 5, 4, 3, 2, 1. That's 5 factorial spread out. And I'm going to keep this at 7 factorial here at the end. So try to cancel out the highest factorials you see. I think this part is not too much to ask. So I'm just going to ask you this. For example, you see a 5 and a 10, right? You notice that 5 goes in here once, goes in there twice. So now you've kind of simplified it a little bit more. 4 goes, right, 12 and 4, you notice that there's a common factor of 4. 4 goes in here 1 time, goes in there 3 times. What else can we do? 3 and 9, correct? Hey, 3 and 12, would that work as well? Yeah, it would have worked, so it works out regardless. 3 goes in here 1 time, goes in there 3 times. 2 goes in here 1 time, goes in there 4 times. So really, at the top, you're left with 3 times 11 times 2 times 3 times 4. And then the denominator, you're left with 0. No, can't do that, right? It's just left with 1. And so this you should be able to compute, and that is 792 teams. You try that. You don't trust me probably. It's like, I don't know, this looks fishy to me, right? So 33 times 6 times 4, 792 right there, right? And same if you would have typed in, let's do that 12 combination 5. Do that please with me. You got to go to math, probability, and you thought you'd never use it, but there it is, right? NCR, right? So 12 combination 5, still 792. So that should jive, right? You can always check if you're doing it right. By the way, I do a lot of copying and pasting when it comes to the combination and permutation. I don't want to go and look for it every time. Okay. How are we doing time-wise? We're still good. I kind of want to skip this for now. I feel like this is just plugging in and go just like I did here. Okay. So I'm going to skip this for now. but I'm doing combinations, permutations side by side. I will do that tomorrow, okay? Can you handle that? I think you do. I want to do word problems right away. Let's get to the meat and potatoes. I love ice cream, so you'll see a lot of ice cream questions, a lot of pizza questions, so you know where I'm going, right? How many ways can you pick 3 different flavored ice cream scoops from 10 available flavors, right? So let's just do this. Sorry, not artistic, right? That's not my strength here. But if you have 3 scoops, right? Look at that. Let's say you have strawberry, vanilla, and chocolate. Does it matter? Like if you ask for those 3 flavors, does it matter which one they put on first? Doesn't really. I mean, don't give me that. Don't give me that. I know some of you is like, yeah, it does matter. I like my chocolate first, and then right, like, but in reality, we're talking about the same arrangement, right? It doesn't matter which one comes first, right? So order does not matter. Can I do that? I think you'll appreciate that one, right? Order does not matter here. Therefore, combination. Combination. So this particular question is really just from 10 flavors, choose 3 at a time and don't double up, right? Like saying strawberry, vanilla, chocolate or chocolate, strawberry, vanilla doesn't matter here. And combination takes care of that. It gets rid of those double, triple counting, okay? Can we just type this in? I want to type this in. I don't want to waste time. So I'm going to copy that. And I'm going to overwrite that 12, turn that into 10, turn the 5 into 3, and there it is, 120. 120 ways that you can be served different cones, so to speak. And so let's say you would have done 10, pick 5, right? So math. So let's say you get 10, pick 3, sorry. So you would actually be at 720 because it would consider the order, the position of the scoops as different cones essentially. But in this case, the 120 is the one that applies, okay? Let's go for this one here. I probably won't be able to finish this one, but that's okay. I'm okay with that. I think you're going to get the picture after the first couple. Given 5 juniors and 4 seniors, right? How many ways can teams of 4, watch this, teams of 4, that is a dead giveaway for what? Combinations. It doesn't say what the roles are, what the positions are. It just says teams of 4 combination, exclamation mark. Oh, now it's factorial. No, that's just combination, right? What if there are no restrictions? No restrictions whatsoever. Listen carefully. This all it's saying is that you have 9, right? N is 9 individuals, people. Okay, there are 9 to choose from. So if there are no restrictions whatsoever, doesn't say how many juniors you should have on the team, how many seniors, then you just go 9, choose 4. And you're gonna just have to trust me that that's 126 teams. Okay, no restrictions whatsoever. How about if the question says, hey, you have to have exactly 2 juniors need to be on the team. No more, no less. Exactly 2. Are you ready for this? That means, if this is what they're saying, that means that there's going to be 2 juniors, right? Sorry, my J looks funny. So how many seniors will I have to make that team of 4? 2 seniors. Okay, always remember that a lot of students just focus on the juniors, but remember, you still need to make a team of 4, so 2 and 2. Can I actually do this? I want to make this very 2 juniors and 2 seniors. Okay. What does and stand for in math? Times. Right? So that means, watch this. How many juniors do you have? 5. So from the 5, I choose 2, got it, times, how many seniors are there? I have 4 seniors, and I have to choose 2. So 5, choose 2, and from the 4 seniors, choose another 2 because you need a team of 4. Got it? So let's do a little bit of math here. You go click, 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 right? Go up here. I know the answer. I have it right here, but 5, choose 2. That's 10, right? So I'm going to go 10 times. You'll go copy because I need you to know how to do this quickly because you're going to run out of time if you don't. Okay? 4, choose 2 is 6. Okay? So there are 60 teams that can be made with exactly 2 juniors. 5 minutes. I don't want to do D. I know I need more time for D and E, so I'm going to leave that one. We'll just do this one more here. What if you need exactly 3 seniors on the team? So you need 3 seniors and therefore 1 junior. Because remember, we're always making teams of 4, regardless of what the restrictions are placed on us. So if 3 seniors, right? So there's 4 seniors. I have to choose 3, and from 1, I need 1 more junior from the 5 that are still there. So I need to choose 1. How about this? 3 and 3, right? The 1 junior here. Poor junior, right? The 1 junior joining the varsity team, right? So 4, what does 4 choose 3? Do you remember that? N minus 1, that's just 4. And what's 5 choose 1? That's the cheat that I gave you. It's actually 5. If it's any number choose 1, it's always that number. So if you remember that one, it's going to save you a lot of grief. So that's 20 teams. I wanted to get this rolling. So how about this? When it comes to homework, I want to give you something you can actually do. So give me 1 second here. Because you for 1 second, guys. Combination. So this is actually 4.6 as well. I want you to try at least a few. So ready? Page 280. I'm just going to give you a few here. 1, 2, 6. And there's one more thing that I forgot to tell you. That the textbook uses an alternative way of doing combinations. This exact same thing, they sometimes just give you a bracket that looks like this. So the top number is N and the bottom number is R. So they can either give it to you like that, or they can do this, which means the exact same thing. You're using this formula, or you're typing it in using NCR. Okay? So if you see that, don't be scared. It's just the same thing. Thank you, guys. That's all I have for today.